Okay, first things first, thanks for the talks. I was interested in this idea of integrated assessment and sort of putting society and nature together in one model, right? And I'm sort of interested in how historically certain anthropological programs informed just how you model society there. And if you could perhaps talk a little bit about that, how that was operationalized and then showed up in the particular methods that were used for integrated assessment. Thanks. Well, basically how you imagine humans to be, and whether that was sort of cultural specific or what kind of knowledges played a role there in conceptualizing and formalizing human behavior. Was it sort of behavioral science or, you know, these sorts of ideas?
Yeah, good question. Thank you. I would say that, I mean, these models or these initiatives, I mean, it's a broad epistemic culture. It's not just one model that is built by one scientist or so. It's a huge scientific undertaking. And I would say that, of course, these relationships became critical in the 60s and 70s with the feeling that environmental resources might become scarce or so. So I think the anthropos of these models is the industrialized, northwestern, more or less civilized anthropos, and how to sustain this kind of development and this kind of logic, and how to make it, how to combine that with a sustainable or a sustaining planet, so to speak. So, I mean, that's nothing new, but I think really this is the anthropos of these kind of models.
Sorry, just a few things. I'm not sure I'm completely in the question, but these integrated assessment models are also kind of very limited in scope. So at the end, they need to have in certain things, mostly in the climate, scope. They will have energy systems, say the prices of different energy technologies, coal and nuclear power and that kind of thing. Projection of how these prices may evolve in the future. The assumption that the actor, so the human here, will be more, actor society that to decide, okay, at that point, I want to have that much energy with at the least cost, and I want at the same time, say, to respect the climate goal. So we'll just have this, say, we'll have trade different between countries based on classical economic theories. Possibly every actor want to maximize his own profit and handle like that. So projection of cost of individual things, technology, assumption about discount rate, how much you invest when you have money. You need to make an investment. How much is it all valid? If you will have a gain in 100 years or nowadays, generally not. If you have money, you would rather spend it today, or if you have a gain, you would take it today rather than tomorrow. Sometimes you will even take half of the gain today rather than the full gain tomorrow. So you have this called discount rate, how you deal with the future. And this is a very uncertain parameter. You see, it's probably also very culturally related. No? What's the discount rate? Maybe, I guess in Germany, you would the responsible way of dealing with the future. You would, and maybe in other countries, you will just forget about tomorrow, just do everything today. Or death is close, whatever. These things play a role, of course, but at the end, it's a model parameter, discount rate, what value you put on it, and you optimize the cost. And of course, there are different contexts. There's more and more event in there, and more what you hear, which is not integrated assessment only models. Because this one is really for emission scenario, energy, technology, trade, that kind of thing. We have also models that develop that try to include more humans and try to investigate threshold within human groups, or with like I remember some people at the institute work about like fishermen and pond, and they have different practice of fishing out everything out of the lake, or be slowly more sustainably. They can communicate among each other, and they have very few parameters, but some of them is how much they communicate, how much they anticipate the future, and that kind of thing. And they investigate the different thresholds and critical number of fish that before society collapse or not, but really at the stage it's a really conceptual model and try to investigate dynamic like that. But it might be that humans start to have more and more roles and role of communication, of network, as your friends, how communications also evolved, idea, okay, maybe climate change is an important thing we should deal with, but half of people I know in the US don't think about the climate hoax. So how then you start having all the thresholds within the society, how based with communication and how political system work and all this kind of thing. So people want to start working on that because this uncertainty itself starts to be maybe as important as uncertainty in the physical system or how to deal with that. But yeah, that's work in progress, but many people are starting to go in that direction. But IAM, integrated systems model, are quite trivial in comparison.
So is the research program then to make kind of a real-time climate assessment? Real-time climate assessment. When you spoke about the the climate tracker and climate analytics, it sounds like a kind of big data-based real-time assessment of climate and to manage it. Kind of.
That's one way. Well, we can see the probably should be the model itself. The analysts look at what the decision makers are, deciding and doing. Go to the media with themselves, put some pressure on the politicians and feedback to the politicians. So you have, if you would model everything, you would have to take into account this actor itself, the entities themselves in the process, of course. Yeah.
More questions from the audience? I'd be interested in notions of integration and I mean it's a very technical question, but integration is a term that always comes up, like how to integrate different equations because in a way, I mean, like, not that I know that much about it, but like I think all of your talks, I mean that's also the way we kind of like framed it, about integrating the physical world and a model, either a computational model or in your case like a very physical model. And I'd also be interested, like you mentioned first principles a couple times, and then also created like a juxtaposition between first principles and physical systems, and then financial systems and other things where they're like much more difficult to find. So I'd be interested in notions of that.
Yeah, this is a very fundamental, of course. I mean, in physics, at least, you have the laws. You have, it's evolved through centuries. You have description of how two molecules of water move near each other and have a river flow. If you had immense computational power, you could really model flow a river like perfectly if you know exactly the bedrostness and all that. The question remains technical. One, then, how to solve it numerically, because the equation is complex. It's a numerical problem. Then is climate. And we start to go to the next step, because some processes, or you start to have biological processes, or could there are some, now you start having different plankton, they need to do photosynthesis, they need nutrients, and you have with experiments, you have some equation of how, bacteria or phytoplankton, they divide, how much they reproduce, how much it depends on the nutrient they take. So you can also have some equation in that, but already it's more complex because there's there are millions of various plankton species. Yeah? So you already start to have to make an exercise. Say, okay, from this million I'll take 10, and they call this my functional types. This one is good because it takes azote and N2 from the atmosphere. Another will do, has a silicate shell, so it will sink faster, and so it'll be better at bringing down CO2 to the bottom. This one is, has this specific role. So they kind of will represent all the others that are in the same sphere. So these biology start to be there. You still have laws, but you already have to play more. Then you start with in economy, of course. Well, that's not my field, so I can't talk so much about it. But they are also based on the role of assumption. Just take bigger roles, Okay, first the question of before, how humans are represented. Should they maximize profit or what's their role? Are they purely rational agents or market that exists perfectly without competition, all that? So you have many assumptions that. So then maybe I'll stop talking about it so much because it's then it will start to be my own opinion. But maybe one important, more conceptual thing is that models in economy, because of these assumptions, rely a lot on parameterizations, calibration, so of past data, or they relate things. They have so many free parameters that really you need past data to calibrate these parameters, and based on the data you do the projection. And sometimes there's a pure statistical model, which has pure nothing to do with any principle, but they relate variable A to variable C, D, and 10 others in various ways. Or C, there's some, you have to choose the relationship, the form of the relationship, so it's based, of course, on still some understanding of dynamics. There's so many freedom parameters, so it's just almost a statistical exercise. So this is a very different from these first principles, where you do not question the laws, you may question, what you put in there, just for water and eddies, that's it. That's easy. And the more elements you go, and the more you have to make up some assumption that explain or something, but it's become more subjective.
And what's the strategy to where, is it more computational power? Is it better models? Is it better, or is there, is that,
Now, of course, the more computational power helps, but, well, you can double, but then you will double the model resolution. Instead of 100 kilometers, it will be 50, or no, even more than double, because you have 3 dimensions, so 1,000 times. So, fine grid, you can do that, but it will never be fine enough. It will fine enough. Finance, sorry, I didn't listen. Finance. To move forward. Well, that's unfortunately I'm not from this field so much. So, but you have to be, you have to have very specific scopes, and know what you want. It's completely crazy and unrealistic to think you want to have the whole world in the mold. No, it makes no sense. Just because, but maybe to study a specific purpose, then you will be interested in particular dynamics which involve, I don't know, why not media, politicians, and and citizens in a democratic system. Okay, so if so you will start saying, okay, what are the possible mechanisms? And maybe you will find, with that making 5 assumptions about how the things interact with each other, you will already emerge from this simple model. You will start having some patterns of things before the election, or some interesting patterns happening. But this will be like a simplified conceptual model of interaction between a number of components you are interested in, and emerge dynamics. So it's a very minimal way of studying complex interaction and feedback between a limited number of components. That you can do, and that is interesting. You can really gain understanding. But of course, a big model with everything is not possible. No, what should you include? No, yeah, too many things. No limits.
I was just thinking, like in general, like this module, like if you say you can like approaches to model like the whole thing, including like politics and finance markets, but there is so many irrational systems in it. How can you model it? There could like go one person, politician or whatever, go in one direction and destroy like in just a fraction of a second your whole prediction, kind of. Yeah. It's about reality. Yeah. That was not my intention. So it was a kind of just for me a way kind of to. There's this constructions of the systems that they have a history in engineering and in math that kind of produces machines to generate rational way knowledge, and this was just the way kind of to work against it, to say like if I just take this raw material and kind of kick it into some kind of feedback process, so it doesn't have any purpose anymore and doesn't have to be. It's not about rationality anymore. It's about like a aesthetic experience in a way. Yeah.
Question for us is because of the results of the experiment. Why the politician would destroy your simulation because it does something different from what you predicted? That was your fear.
No, it was just in general like how you can, like if you have like an integrated model that kind of models everything, but there things, you cannot model the because there are people involved, you cannot model the brain of each person, what kind of irrational decisions somebody does, kind of. I mean, it's just not, don't want to answer something, I just want to kind of, I don't know.
But you always can find constraints and some general rules, and maybe it doesn't work for one individual, but for a bigger number, or one person you need to eat, need to earn some money, need to this and that, have general weight, but models describe averages in general.
It's as if you were comparing trivial and non-trivial systems, yeah? You can understand weather, but you can understand people. Bateson always said, if you kick a rock, you can precisely calculate where it's going to end up. But if you kick a dog, it's a non-trivial system and something surprising might happen.
That's a very nice quote. A final thing that I'd be interested in, if there's is this magic model that you mentioned, because it looked like it's actually, I mean, since it's an emulation, it looks like it's a model of different models, which then to me would also a bit relate to like Ralph's work of actually like emulating certain computers in like a different medium or going back to the materiality. So I'd be really curious to know a little bit more about that and what the significance of that, maybe also in contrast with like a possible real-time thing, is at the moment.
Well, you may be disappointed with the answer, because that's at the end, its structure in that case it's just like a climate model, but simpler. The only difference is that there's much more than you can parameterize. For example, in a bigger model, there are inside carbon cycle and many things, so that if you put more carbon in it, it will influence, I don't know, carbon absorption, whatever, plankton, trees, and at the end, you warm up and this interaction with ice, and at the end you will have a certain warming. If you double carbon, you'll have a certain warming. It's something called climate sensitivity. In this magic model, climate sensitivity is a parameter. You can say, okay, this particular setting, the model will warm up by 3 degrees if you double climate CO2. So it's a parameter. So the only difference in that case, it's more like in physics you would say interpolator, or based on an ensemble of other simulation or models, I mean, or several scenarios. Say you have one model that does several scenarios existing. This one you would choose certain sets of parameters so that it will reproduce this more complex model in each of these scenarios, and therefore if you do a scenario somewhere in between, it will, you can have a reasonable, trust in that it's maybe the bigger model would do also the same, so it's as long as it's remain within the same model, because it has some physics in there, there's some dynamics, like it has an ocean absorb heat, so it has time per of heat penetration in the ocean, heat control, some physics, but yeah, at the end it's the same but simplified, just more statistics. Integrating the model running on the computer. I mean, the other bigger models are just fed in as input-output relationship. And this is, in general, statistical emulator. It doesn't have to be image, it doesn't have to be that shape. It may be purely statistical, a neural network, or a human being, you see, okay, this scenario is this warm, and all the scenarios that warm, what would it be if it were in between scenarios? Okay, you can just guess it. And you are doing already that interpolation. You don't know, actually, we just saw the two figures and you're okay, it's in between. Of course, in that, with 1.2, you have 2 lines, but then you could do that with emulator on more complex things that may be also spatially different or really not so obvious, relation between input and output. So you can construct emulators. So the basic idea is, you take the world, or you take more complex models and try to reproduce this relationship between input and output. The input will be how much you emit. The output is the specific climate impact you're interested in. Yeah, and that's close to statistic, and the specificity of this magic model is actually, it does the same, but with a bit actual physics inside instead, and the model parameter you choose are based on physics.